All right, so we're just picking up and refreshing our memory on the degree and number of terms pieces here. So for that first one, what is the degree of that? So in other words, what's the highest exponent on that first one? Well, there's no x there, and when there is no x present, that means it's degree 0. And so that's why, yes, it is constant. Now, a little detail on this one. Every single constant can only have one term. So in this particular case, you actually are allowed to just write constant if you want to. This is the only type where you can only list one word. But if you list constant monomial, that's not wrong. That's still good, because yes, it is constant and it is a monomial. It's just that every constant is a monomial. All right, and then we go through the same kind of thing for the next few. So for the second one, 8x squared. It is second degree, therefore it is quadratic. One term, quadratic monomial. The one below it, the highest exponent there is the 2. So again, that one's quadratic. But that one is a binomial. But now to be a little bit tricky, the last one is not a quadratic binomial. I was tricky on you there. Do you see why? We can simplify it, right? And so if I combine the like terms, it actually equals 9x squared. So it's actually quadratic monomial. All right, so just a little bit of practice, a little bit of a refresher there. This is new because I've never given you an equation where we have it equal already to a plus or minus a number. So this is something we're going to have to use a lot today. So I'm wanting to start with just this equation to show you how we deal with it. And it's all about the plus or minus. Remember, meaning two separate numbers. This plus or minus 7 actually means 7, and it means negative 7. Therefore, if I want to solve this, I really need to treat it as two separate equations. I have one where x plus 9 equals 7, and I have one where x plus 9 equals negative 7. And so whenever you see this type of thing, we actually got to split it up into those two equations, and then we can solve those. And so in order to solve each of those equations, let's go to the first one here, the left one first. What do I need to do to both sides? Yeah, we need to subtract 9, right? And so I subtract 9 from both sides, and that gives me x equals a negative 2. Great. For the second one, what do I do to both sides? We subtract the 9 again. And in this case, when I do that, notice it does not give me positive 2. One assumption that people make is that, oh, well, it was a plus or minus at the start, so it's going to be the same two numbers at the end as well. But it's not. Because negative 7 minus 9 actually gives me a negative 16. And so that's our actual solutions. And so x equals negative 2 and x equals negative 16. If you want to, you can actually write it just as a single solution, where you would write x equals negative 2, comma, negative 16. That means the same thing. So you can give your answer either way. You can give it x equals, or just one x equals with the comma in between. Having done that previous one, you should be able to do both of these now. So go ahead and solve each of these two problems, please. All right, so the first thing we do for that first one is I'm just going to split it up into two equations. For the moment, I'm not worrying about the other equation. I'm just going to do this one at the moment. And so, once I get it to this point, you notice I have negative 2x equals and negative 2x equals. When I see negative 2x, what am I doing with the 2 and the x? Am I subtracting or am I multiplying? They're written next to each other, so it's multiplying. And so, because I'm multiplying them, I'm going to divide both sides by negative 2. So I divide both sides by negative 2 on the first one. That gives me x equals a negative 5. On the second one, when I divide both sides by negative 2, that ends up giving me x equals a positive 5. So, in this case, x equals negative 5 and 5. Or, if you just are all about efficiency, because it's the same number, you could write it as x equals plus or minus 5. That would also be fine there. But then we need to take a look at the second one. Now the second one sets up the same kind of way. where I'm going to start by splitting it into two equations. So I have x minus 2 equals 10, and x minus 2 equals a negative 10. In this case, what is going on between the x and the 2? Is this subtraction or is this multiplication? It is subtraction. Why did I choose these two particular problems? Because every now and then some of you get mixed up about, am I multiplying by negative 2 or am I subtracting? Notice what causes what. When the negative 2 is just written next to it, that means multiply by it. When you see that minus between them, that's telling you that it's actually subtraction, not multiplication. And so if that gives you a little trouble, put a little star on that on your paper so you can remember that, because I don't want it to give you trouble in the long run. All right, so in this case, when we add the 2 to both sides, we get x equals 12 and negative 8, which if you wanted to write it all on one line, you could write 12 comma negative 8, or negative 8 comma 12, or you could go ahead and just leave it as the two individual statements. Any of those are fine. Now to bring it back with the other piece that we're going to be combining this with, let's go ahead and solve this equation. This is the sort that we saw how to solve yesterday. So write it out and solve it. All steps shown, please. Now, once you get to this point, we got 25 equals x squared, and now we have to remember the new stuff from yesterday. How do I get rid of the squared? We square root. Now, when I take the square root of both sides, there is something I have to remember. What do I have to remember when I put the square root in?
Plus or minus?
Yep, that plus or minus in front of the square root. Because remember, there's two numbers that I can square to get 25. I could square 5, but I could also square negative 5. And so we have to remember that plus or minus on that. Which is why we were practicing the plus or minus equations earlier, because we're going to be solving more quadratics now, and they're going to have to involve some of those other operations we were saying. All right, now this problem, it's very similar to the type that you were doing yesterday, but there is a little bit of a variation. Because you'll notice that the minus 2, it is stuck inside of parentheses here. I cannot add 2 at the start of this problem. It's trapped inside the parentheses. So I got to work from the outside in this case then, which means getting rid of the squared first. So the first thing I'm going to do on this problem is I'm going to take the square root of both sides. Now when I take the square root, of course, I have to remember that plus or minus. I put that plus or minus over there with the number. And so when I take the square root of both sides, I end up with x minus 2 equals a plus or minus 10. Well, this should seem a little familiar, right? Remember how we solve this? I break it up into two equations because it's plus or minus 10. And so we do x minus 2 equals 10 and x minus 2 equals negative 10. Add the 2 to both sides. And this should seem very familiar because once we got it to that point, it actually was the same problem as what I gave you just a couple problems ago, where x equals 12 and negative 8. So you notice that by having the number inside of the parentheses like this, we're no longer getting plus or minus the same number for our answer. We have to actually split it up into the two equations and do what we were doing at the start of class in order to solve it from there. We're going to do the same kind of thing with this problem. So go ahead and write down and even solve this one. If you get stuck, at least get up to the point where you feel a little stuck. All right, so when we go to solve this one, the difference between this and the last one is that this one has that awkward plus 3 hanging out at the end. Well, get rid of it first then. So the very first thing I want to do here is subtract 3 from both sides. And when I do that, I have x minus 5 squared equals a 16. And now it looks just like the previous one, just with different numbers. All right, now in this case, as we did all of our work and we got to the point of taking the square root of both sides, you'll notice that if I take the square root of the left side, I get x minus 9, just like normal. But on the right side, I have plus or minus root 0. First of all, the square root of 0, yes, we can actually do that one. The square root of 0 is 0, because 0 times 0 is 0. But the plus or minus thing, positive 0 and negative 0 doesn't make sense. It's the same thing. 0 doesn't even have a sign. So in this case, x minus 9 equals 0, and that's all. We won't end up with two separate equations because there only is the one. And so then we go ahead and we add the 9 to get our final answer. And so here, x just equals 9. All right, now, having done those, we're going to go off on a slight tangent here, where we've done all the heavy lifting here, but I want to take an opportunity, since we got a little bit of time in this class, to do a little bit of practice on some basic fraction stuff, just to make sure we're all solid with our fractions. And so we're going to go through a series of problems really quick just on multiplying fractions, to make sure we remember how to multiply. And so write down this problem, and you're going to find that you can write them down about as fast as you can solve them, especially once we really get rolling here. So we're going to cruise through these. All right, so our rule for multiplying fractions is just that we're going to multiply straight across the top and straight across the bottom. And that's all. So if I multiply straight across the top here, 5 times 1 is 5. On the bottom, we multiply straight across, so 6 times 2, that gives us 12. 5 twelfths, that's it. That's our final answer right there. All right, and in this case, you'll notice that that fraction does not reduce. I'm not going to worry about you reducing your fractions right now. I just want to make sure you got the idea of multiplying down totally solid. All right, so go ahead and do these two problems really fast. Yeah, these will be quick for you. All right then, so for these, again, we're going to multiply straight across the top, straight across the bottom. So for the first one, that is the one on the left, we do 2 times 4 on the top. And that's just going to give us an 8 over, then we do 3 times 5 on the bottom, 15. That's it, you're done. Multiplying is the easy one, right? And so for the second one here, 5 times 1 on the top, 2 times 3 on the bottom, 5, 6. You're done. I like multiplying fractions, nice and easy. Of course, sometimes things come up where we're not quite sure how to handle them. And every now and then this might throw you off. One's a fraction, the other one's a whole number. What do? Well, when they're both fractions, we know what to do, so let's make them both fractions. How do I write 6 as a fraction? 6 over 1. And if I write it as 6 over 1, then it's much easier to do, because I can now just look at it as still multiplying across the top and multiplying across the bottom. And so 4 times 6 on the top is 24. 5 times 1 on the bottom is 5. So 24/5 is our answer. And again, I'm not going to worry about you simplifying these, reducing them. You can leave them as improper fractions. That is top heavy. You don't have to go into a mixed number. This is fine as your answer. Not going to worry about making them any more complicated than this. So then, just 2 more here. Go ahead and multiply these. Make sure you got the idea down. All right, now for that first problem, that is the one on the left, we're still multiplying our fractions using the same rule. But did I catch you off guard with this one? No. We'll find out. On the top we do 3 times 9, so that gives us 27. Okay, that's no problem. But on the bottom, some of you were looking at that and you're like, oh, common denominator stays the same. That's when adding. That is not true for multiplying. With multiplying, we still multiply it. So I still have to do 4 times 4. So it's 27/16, yes. So multiplying, doesn't matter if the denominators are the same or not, we still just multiply straight across the top, straight across the bottom. And then for that last one, of course, we write the 11 as 11 over 1, multiply across the top, multiply across the bottom, and you're done. Okay, so multiplying fractions, hopefully we're going to have that nice and solid. We're going to be coming back to using that, of course, lots later. But since this is a nice, easy one, I figure you can also handle maybe a good word problem with it. So let's take a look at this word problem and see how we can then apply our fraction work to it. So you notice the situation we have here. Half of the questions on a test had negatives in them. A third of those questions, the fact that it's of those is important here, had variables in them. And we want to know what fraction of the test questions had both negatives and variables in them. So I'm going to just kind of represent this pictorially first. So we got a whole list of problems, and of those problems, half of them had the negatives in them. Now, of those problems that had negatives in them, 1/3 had variables in them. And so what I want to know then is what fraction of the whole is that grouping. In other words, that third of the half is how much? Well, you notice how I phrased it there. It is a third of a half. Whenever I can say of, what operation does that tell us we can be doing there? Multiplication, yeah. Whenever you see or can say of, that's going to mean multiply. And so then I'm going to take the 1/2 and I'm going to multiply it by the 1/3. All right, and we just went through a quick review about how to do those, right? So I multiply straight across the top, multiply straight across the bottom, we get 1/6. That's our final answer there. That's all we got to do. So nice little variety in class today, right? We did some heavier lifting with solving quadratics, and then some lighter stuff with the fractions. Well, that's because, sometimes fractions still give us trouble and we got to be solid with them. I'll tell you, you got to be solid with them because we're going to go to some new places with fractions by the end of this year, and especially next year as well. Because pretty soon, you're going to be seeing what we call rational expressions, which is where you have like variables in your fractions that you're going and multiplying. And so we're going to have to be able to see how to multiply with the variables in there, and if we got our fraction rules solid, those will be easy. But if the fraction rules are a little suspect, those are going to be really nasty. So we start by just working on the fractions.